All right, welcome back, Patriots. This is going to be a little bit different today. The reason I've got my mask on is because I'm actually recording live in class. I finally got one of my Alg2 2 classes. We got all of their media releases in, so it's okay for them to be on my video and their voices can be heard and all that sort of stuff. So class, go ahead and say hi.
Hello.
Hi.
Yeah, they sound really excited, don't they? They're on YouTube right now. Be more excited.
Hi.
Okay, fine. All right, so here's how this is going to work. We're going to run through the review just like I would in class because I am in class, and they're going to ask questions as we go through, and if they ask a question, I will repeat it back for you guys so y'all can hear it online later on. So first thing we want to do, make sure you have some of your formulas down. Key ones you need to have is axis of symmetry. X equals negative b over 2a, extremely important, going to be used all the time. Also, know the difference between your vertex and your standard form. Standard form, remember a, b, and c are just the coefficients of x squared, x, and then c is the constant. Remember, c is also very important because that is the y-intercept of a graph. Also, for vertex form, remember that these ah and k correspond exactly to the ah and k that we had on the parent unit, or the parent function unit. I think that was unit 3 or 4. So you've got horizontal shift, vertical shift, and then stretch and reflect. So let's go ahead and go through here and see what we come up with. I've got the calculator up just in case I need it. Okay, so first off, we're going to be graphing this one in standard form. So whenever it was in standard form, the first thing I did was find the axis of symmetry, which is negative b over 2a. And now we go ahead and plug in negative b is 4 over 2a is 1/2. Now I see students who are making mistakes on this particular spot. Make sure you simplify the top and bottom before you move on to anything else. So that numerator is going to be negative 4. The denominator is going to be 2 times 1/2, which is just 1. So the whole thing simplifies down to x equals negative 4. So axis of symmetry. Okay, now our vertex. We go ahead and find the y value, but we're going to plug in the axis of symmetry for the x value. So we got x, or y equals 1/2 x squared plus 4x plus 7.5. And we're going to put in negative 4 for both of those. Now we simplify down. Well, change my color. Okay, negative 4 squared is positive 16 times 1/2 is 8. 4 times negative 4 is negative 16 plus 7.5. Now we've got that 8 minus 16 is negative 8. Plus 7.5 is negative 0.5. So my vertex x coordinate is negative 4 because that's off the axis of symmetry, and then negative 0.5 as the y coordinate. When I go to graph that, let's go to negative 4 and put our axis of symmetry. And then negative 4, negative 0.5. I'm going to zoom in really good so I can get a good spot there. I realize you can't zoom in that well with your paper, but you do the best you can to get it at 1/2. Okay, next up we need the y-intercept. The y-intercept is going to occur at the c value. So it's just 0, 7.5. So I go up to 5, 6, 7.5. And then because of the axis of symmetry, we're going to take that one and reflect it over. So that is 1, 2, 3, 4 away. 1, 2, 3, 4 away. And then I can go ahead and draw my rough sketch of the parabola using those points. Now, the max and the min. Well, because this is the bottom, that's going to be a minimum value, and the minimum value is negative 0.5. Domain is negative infinity to infinity for all of our parabolas. Range, the minimum value is negative 0.5, and the positive side is infinity. Now our solutions. Remember, solutions is x-intercepts. It's also answers, roots. It's a place that crosses the x-axis. Now there's a few options we could do. We could solve it. I prefer to do it from the graph if we can. I kind of was a little bit, I don't know, I freehanded that down in there, so I wasn't really strict on where those points were. I'm going to go ahead and do the second part of that, graph, the graphing thing that I didn't do earlier. I had you guys graph putting x and y, and then the points off the parent function chart. Then multiply those times the a value, which here is 1/2. So that's going to be 1, 1/2. 4 times a half is 2, and 9, that should have been 3 there. And then that 9 times a half is 4.5. So from our vertex, we've got the point 1, 1/2. Well, if I'm going up a half from a negative half, that puts me at the 0 right there. And that point gets reflected over as well. Then we're going to go over 2, 2, 2, 2. So that one I hit, that one I missed. This one should have come in more like this. But anyway, my point is it crosses the x-axis at these 2 points here. That was a bad highlight job. At these 2 points here. So that's going to be 1/2 off of negative 4. So that looks like it's going to happen at, well, the y-coordinate is 0 for both. It's going to happen at negative 4.5 and negative 3.5. That one was nice because the table told us exactly where they would be. Okay, any questions on that? Any part of it? Okay. Yeah, we've been doing these standard form ones enough that they should be kind of be second nature by now. Okay, let's go ahead and do our axis of symmetry. X equals negative b over 2a, which is negative b is 4. 2 times a is 2. So simplify that down. 2 times 2 is 4. So negative 4 divided by 4 is negative 1. Fill in all of that to the appropriate places. Also, let's go ahead and come in and draw the axis of symmetry. Now the y-intercept is going to be negative 3. So that's 0, negative 3. I need to finish finding the vertex. Y is equal to 2x squared plus 4 minus 3. Plug in negative 1 on both of those. Negative 1 squared is 1, times 2 is 2. 4 times negative 1 is negative 4, minus 3. And then 2 minus 4 is negative 2, minus 3 is negative 5. So negative 1, negative 5. Looks like this one is also going to be a minimum. I can see that because it's going to go up this direction. Let's go ahead and finish graphing that. Get our XY chart. 1, 1. 2, 4, 3, 9. This time I'm multiplying all of them by 2. 1 times 2 is 2, 4 times 2 is 8, and 9 times 2 is 18. I don't think I'll be able to fit that one on here though. So now let's go ahead and graph our point 2, 8. off of the vertex. So I'm going to go over 2, up 1, 2, 3, 4, 5, 6, 7, 8. The reason I skipped 1, 2 is because we already have that. That's the y-intercept. And now let's go ahead and reflect those points over. This one goes here. Then this one goes here. And now we're going to graph. Domain. All real numbers. Range, here my bottom is at -5 to infinity. And you'll also notice on this one, I did not ask you to come up with the zeros. The reason I didn't ask you guys to come up with the zeros is because they're not too nice on this one. Over here, I found them easily based on the table. Number 2, it's not going to be so nice, so I just left that one off. All right, number 3. Well, any questions on number 2? All right. Number 3, axis of symmetry. X equals -b over 2a. B is 12. A is -3. Simplify that down, we get -12 over -6, which is +2. Go over to +2 and draw it. Y-intercept is going to be -13. So I'm going to go ahead and plot that point and go ahead and reflect it over just because I'll save myself some trouble later. Now the y-intercept, the vertex, -3 squared plus 12 minus 13. Plug in 2 for both of those. 2 squared is 4 times -3 is -12. 2 times 12 is 24. And then -13 drops down. Well, -12 plus 24 is going to be +12. Minus 13 is -1. So we've got the point 2, -1. Let's go ahead and do the XY chart. 1, 1, 2, 4, 3, 9. Multiply that by the -3 value. So 1 times -3 is -3, and then times 3 is -12. So I go over 1 and down 1, 2, 3. Goes there, reflect over becomes there. Then if I go down 12, that's going to put me right here at these points that I derived from the y-intercept. So this one looks like it is going to be a maximum because the vertex is at the top of the parabola. Domain, as always, is -infinity to infinity. Range, this time, the bottom side is -infinity. The top side is -1. Also, you notice that I don't ask you for any of the x-intercepts or solutions or roots because there are not any. Actually, what's going on here is this one would, if I was to try and factor it or get solutions, it would have imaginary answers. And so we can't graph imaginary answers. That's why it doesn't cross the x-axis. All right. Page 2. Sorry, mine doesn't display pages. Is it the end of the first page? Yeah, okay. Now, going from the parabola to the equation. Now, remember, at home, you can do this in Desmos if you want to. I'm going to be using the calculator because that's what you guys are able to use on your standardized tests. What you want to do is find 3 points that are on the graph and turn those into a table. So here, the 3 points are marked for us. I got the point 5, 3. I've got the point 4, negative 1. And I've got the point 3, negative 6. Now remember, we go to Stat, then Enter on Edit. If you have anything in this list, you're going to press Up and then Clear, Enter. Go over to L1, Up, Clear, Enter. Now type in all of your X values, 5, 4, 3. Type in your Y values, 3, negative 1, 6. We're going to go back to the home screen, second quit or second mode. Now go back to Stat, arrow over to Calc. We're looking for quadratic regression, so that is 5. Make sure your X list is in L1, your Y list is in L2. By the way, if you're also using an older version of the calculator, it won't even give you this list. Just go ahead and hit enter if it does that. And there we go. Looks like we've got y equals 5.5x squared minus 45.5x plus 93. Just plugging in A, B, and C into the appropriate places. Okay, number 5, exact same idea. My y-intercept is 0, 2. Now, just to review what we've been talking about with that one, we know the y-intercept has to be the c value. So whenever we do this, we are expecting there to be a plus 2 on the end of this. If it's not, we've done something wrong. Then we've also got the point 2, 0 and 6, 0. So, sorry, stat.
Wait, is it number 5? Isn't that 0, 3, first one? 7.4.
Oh, thank you. That, yes, somebody here in class just pointed out that that's actually a 3. I got that in the wrong spot. Thank you. Okay. So we're going to clear our lists. Zero, 2, 6, 3, 0, 0. I'm actually glad you're here, because if I'd done that on the actual video, I would have confused a lot of people. That's why it's always better to record in front of a live class. Okay. Stat, over to Calc, down to quadratic regression. And then all the way down to Calculate, and hit Enter. And sure enough, it did give me a C value of 3. That's good. Okay, so y equals, it has 0.25. I'm going to write that as 1/4. If you had written that as 0.25, that's not technically wrong, but realize with multiple choice tests, pick the one that's appropriate. So 1/4 x squared minus 2x plus 3. Any questions? All right. Word problems. The height in feet of a basketball after a certain time of seconds can be modeled by the function h of t is equal to that. What is the maximum height of the basketball? Okay, now keep in mind that because this is a negative 16, we know that the graph is going to be reflected and it's going to be doing this. So the top point or the vertex is going to be the maximal height of the ball. So what we're really looking for there is the y value, or in this case the h value of the graph at the vertex. The way we do that is by finding the axis of symmetry and then the vertex, just like we've done before. So x equals negative b over 2a. So b is 45 and a is negative 16. I'm sorry, what? On which one? Okay, yeah, so the negative, this negative sign came from this negative sign here. but the 45 itself is positive because of that 45. Now, when we simplify, it'll end up being negative 45 on the next step. So here we're going to have negative 45 divided by negative 32. So when we do that, I know that's going to be positive. It comes out to 1.406. And notice here it says round to 3 decimals, so that's why I'm doing that. Now, okay, that's not the true height of the ball. What that's saying is it happens at 1.406 seconds. Now I'm going to go ahead and plug that in. And so h of 1.406 is equal to negative 16 times 1.406 times, squared plus 45 times 1.406 plus 6. Negative 16 times 1.406 squared plus 45 times 1.406 plus 6. So 37.601. And does it give me units? Yes, that says feet. So 37.601 feet is our maximum height of the basketball. Now, I know this isn't part of the actual problem. I'm going to go ahead and point something out here. The y-intercept here is at 6. So if I was to actually graph the axis on this point right here is at 0, 6, which if we're shooting a basketball, that makes sense that the ball would start 6 feet above the ground because he's shooting from up here somewhere. So when we were doing the football example, it makes sense for the football to start at 0 because it starts at the ground. Okay, playing a lawn version of tic-tac-toe in which you toss beanbags onto a large board. One of your tosses can be modeled by that function. What is the maximum height? Okay, exact same style of problem here. We're going to find the axis of symmetry. So our B is 1.2 and our A is negative 0.12. Okay, so we got negative 1.2 divided by, well, negative 0.12 times 2 is negative 0.24. And I think that's going to be 20. No, 5. I was way off. Okay, it's 5. Now, we go ahead and plug that into the equation. Y equals negative 0.12 times 5 squared plus 1.2 times 5 plus 2. Negative 0.12 times 5 squared. Negative 0.12 times 5 squared plus 1.2 times 5 plus 2. Really? Did I type that in right? Negative 1.2 times 5 squared plus 1.2 times 5 plus 2. Yep. So y equals 5. So the maximum height, 5 feet. So it goes to the 0.55. All right, any questions on those word problems? All right. Okay, 8 through 11 is finding our C value for the perfect square trinomial. We're doing this in order to be able to complete the square, which is what we're going to do in the next section. So remember that we're going to find the C value is negative b over 2 squared. So let's plug in. Wait. It wasn't negative, was it? Actually, it doesn't matter. Just b over 2 squared. Sorry, I'm getting my axis of symmetry mixed up in there. Okay, so our b value in this case is 20. So that's going to equal 20 divided by 2 is 10. 10 squared is 100. Now remember, the way we would do that is you would do a plus 100 minus 100, but we'll practice that in the next section. For now, we're just worried about finding C. Okay, for number 9, C is 6 divided by 2 squared. 6 divided by 2 is 3. Squared is 9. For number 10, b is negative 10 divided by 2. Negative 10 divided by 2 is 5. 5 squared is 25. And then here we had negative 50 divided by 2 squared. Well, negative 50 divided by 2 is negative 25. Negative 25 squared is 625. Let me double check. I believe, yep, 625. All right, any questions on finding our C values? All right. Now we're going to rewrite them in vertex form by completing the square. The way we do that is by finding the C value, adding it and subtracting it on both sides, or adding it and subtracting it to the equation, and then factoring down the first portion. So we're going to first off find our C. So that's negative 8 divided by 2 squared. And you know what, to make this match the way we did the other day, I am going to put those in red. So we have negative 8 divided by 2. So that's negative 4 squared. Negative 4 squared is 16. So when I go to write this, I've got x squared minus 8x minus 16. Just rewrote the entire problem with a little bit of space. Now I am going to add 16 and subtract 16. By doing that, I have added 0 to the problem, which does not change anything. However, this part in parentheses will now factor down to x, and then this b value, or this not b value, but the number we found on the inside will go there. And then we just simplify. Negative 16 minus 16 is negative 32. All right, any questions on that piece? All right, let's do b over 2 is 18 over 2. 18 divided by 2 is 9. So c equals, oh, not 18. 9 squared is 81. Now, we're going to write out x squared plus 18x plus 30. We're going to add 81 and subtract 81. Now when this factors down, this 9 will go on the inside. And then 30 minus 81 is minus 51. All right, any questions on that? All right, moving on to just the last page. I also feel like it kind of gets easier from here on out. So, vertex form. Now remember, the reason this is called vertex form is because you can read the vertex directly off of the equation. Remember though that inside lies, so that x value, we're going to have to change the sign, so that positive 3 becomes a negative 3 on the vertex. However, the y value stays the same sign. So we got negative 3, negative 3. Axis of symmetry is still going to be at negative 3. X value of the axis of symmetry and of the vertex are going to be exactly equal. So I'm going to jump over here to negative 3. And then at negative 3, put my dot. Now the y-intercept is a little bit more difficult to find on these. We're going to have to plug in x equals 0. And so we're going to do y equals 3 times 0 plus 3 squared minus 3. Well, 3 squared is 9, so 3 times 9 minus 3 comes out to 3 times 9 is 27, minus 3 is 24. So 0, 24. And what do you know? The graph goes up that high. It's almost like we intended for that to happen. Okay, so then we're going to reflect that point over. 1, 2, 3, 1, 2, 3. This one looks like it's going to be a minimum value. Domain, as always, is negative infinity to infinity. Range, the bottom is negative 3, the top is positive infinity. And then we can get some more points in here by using our chart. One, 2, 9. So again, our a value is 3. So I can multiply those out. 1 times 3 is 3. 2 times 3 is 6. 9 times 3 is 27. Now we've already done the 27 because that one's right where the y-intercept is. But I can go over to 1, 1, 2, 3. And then 2, 3, 4, 5, 6. Select those points. And then draw the graph. These really tall ones are really hard to draw vertically. It feels like you're almost going completely vertical, but that's fine. Now I realize I could have asked you for the solutions or the x-intercepts on this one, which would just be 2 and or negative 2 and negative 4. Okay. 15. Vertex, again, change the sign on that 6 to make a positive 6 and a positive 4. 6, 4. Axis of symmetry is going to go straight through there, so it's at x equals 6. Y-intercept, plug in 0. Negative 1/2 times 6 squared is 36 plus 4. Now, a half times 36 is negative 18 plus 4 is negative 14. And we do that again. We got 0. Negative 14 fits exactly on the graph. This one is going to be a maximum. Let's go ahead and do that XY chart to get some more points that we can graph. Not 0. 1, 1, 2, 4, 3, 9. So our A value here is negative 1/2. So we got negative 1/2. 4 times negative half is negative 2. And negative 4.5. So we got 1, negative half, 2, negative 2, 3, and then 2, 3, 4.5. Let's reflect those. And then also we can reflect the y-intercept, but there's not really space on there, so I'm not going to worry about it. All right, now domain. All real numbers. Range, the bottom side is negative infinity, the top is at 4. Okay, any questions graphing from Vertex? Vertex Form. All right, 16. Convert to standard form. On these, we're going to multiply out, FOIL out the squared term, then multiply by or distribute the A value, then combine our like terms on the end. So, y equals negative 3 minus 4. Now remember, we talked a little bit about how to shortcut these the other day in the completing the square lesson. We're going to have x squared. Then you take this number and double it, and that becomes your b value. And then you take that number and square it, and it becomes your c value. And with the 2, doubling and squaring is the same thing. So we got 4x and 4. All right, now let's distribute the negative 3. Negative 3x squared. Negative 3 times 4x is negative 12x. Negative 3 times 4 is negative 12 minus 4. And now combine your like terms. Negative 3x squared minus 12x. Negative 12 and negative 4 and make negative 16. Okay, 17 is similar, except there's no distribution step, so this one will be one step faster. Y equals plus 2. We're going to write down x squared. Take your negative 1 and double it. That's negative 2x. Take your negative 1 and square it, and that's a plus 1. And now we've got x squared minus 2x. Combine the like terms, and I've got plus 3. All right. write the quadratic in vertex form. So first off, we're going to locate our vertex, which is right here. Vertex is at 4, 1. We also need to identify our a value. Now remember that the way we identify a, we've got our XY chart that we're using all the time here. We're going to find some point that this graph goes through. So it looks like it goes off of that point there. So here I've gone over 1 and up 2. So that's going to match up with this line, the 1, 1. Now you ask yourself, what did I multiply by? Well, in order to do that, I had to multiply by 2. And so my a value equals 2. That's all I need to write it in vertex form. Remember that we've got a times x minus h plus k. This is my h, this is my k, and that's my a. So we got y equals 2 times x minus h is 4 squared plus k is 1. So there's my vertex form. All right, number 19. Let's come up with a vertex is at 0, 3. And now I've got that XY chart. One, 2, 3, 1, 4, 9. Looks like I go through this point right here, so I've got 1, negative 1. So I have to multiply 1 times negative 1, so a equals negative 1. So now we plug in y equals a, so negative 1 times x minus h, which is my 0 value there, squared, plus k, which is 3. Now, while this answer is, my head's in the way. While this answer is technically correct, I want to clean it up a little bit because, for example, I don't like writing the 1 out in front of the parentheses. I'm going to write this as negative x. Well, and also I don't have to write this plus 0. So this is just negative x squared plus 3. Now, that being said, it specifically says vertex form. So if you were to leave it as y equals negative x plus 0 squared plus 3, that's also okay because it explicitly says what the h value is. So either one of those works. Again, multiple choice tests, pick the one that works best. Okay, find the roots for each quadratic function. Now, roots are just where it crosses the x-axis or the x-intercepts. So I look and it crosses right there. So my only x-intercept here is x equals negative 2. Now remember, when the vertex ends up there, I don't believe we've actually given this a name so far. But that's a double root. That's not important for right now. I just want to bring it up because it will come up in later classes. Okay, looks like on number 21, I am crossing at negative 6 and negative 4. And then at on the 22, it goes through negative 3 and 2. X equals negative 3, x equals 2. My face is in the way.
On number 20, the y is x negative 2, since it was on the x-axis at 2.
Oh, okay. The question was, why did I put negative 2 on number 20? I was used to flipping my h value. That's why. I did it on accident. That should be positive 2. Thank you for catching that. Okay, I also want to point this out because it can happen. If the graph were to do either this or this, in that case, there would be no solutions because it does not cross the x-axis at all. There would be no roots, no solutions. So I believe that's it. Any questions overall? All right, at home, if you guys have any questions, feel free to email me. And let's make sure we get our test done on time within the testing window. I've had quite a few people just not taking it. So as it is, good luck. Reach out to me if you need help.